Hello everyone, so this is my project for the robotics and hence robotic car project. So brief overview. This is the Arduino based rover which is developed completely for the obstacle detection. This rover is upgraded to the obstacle detection. This robot earlier has comprises the component of the mobile communication using the Bluetooth and I2C LCD I2C LCD which is now upgraded. This rover helps in detecting the object and prevent the crash when the object comes at the front. This rover continuously receives the command from the Bluetooth module and perform the desired action. The object detection rover combines with cutting-edge sensing technology, wireless communication, and effective component integration to provide a flexible and engaging robotic vehicle. It has ultrasonic sensor, Bluetooth connection, and I2C crystal module. It features autonomous obstacle recognition and avoidance capabilities while enabling remote operations, letting the users take charge and explore their environment for robotics enthusiasts, hobbyists, and students interested in the robotics and automations. The combinations of these qualities make the object detection vehicle a fascinating and informative instrument. The component used: L298 motor driver, Arduino Uno R3, HC05, potentiometer, and ultrasonic sensor. So this is basically the design for my prototype. It is the potentiometer, hydrogen crystal LCD, ultrasonic sensor, HW module which convert a 16 pin of LCD to 4 pin, an object Arduino Uno R3, HC05, L298 motor driver. So this is the explanation. So my prototype consists of the six main components. Firstly, Arduino, potentiometer, L298 motor driver, ultrasonic sensor, and HC05 module. This rover helps in detecting the object in one direction. The code is stored in Arduino, which acts as the brain of the rover. The commands are sent to the rover using the Bluetooth module, which is HC05. This helps in receiving the signal from the mobile from when a button is pressed. Certain address or the keyword is sent, and accordingly, it detects the keyword and then works. The L290 motor driver helps in controlling the motor as it is based on the H-bridge. We have used L298 because it helps in moving the motor in bi-direction using the H-bridge concept. The potentiometer helps in controlling the speed of the rover. The I2C is connected to 2HW60, which is the 16-pin to 4-pin converter. This helps in displaying the signal through the two main pins which convert the signal are an SDA serial data analog and SCL serial clock signal. Now the ultrasonic sensor help in measuring the detection of an object. Basically how it works. When a rover is moving, it detects the object. The sound wave is sent continuously. When an object comes in front, it reflects the sound waves and come to the receiver. The distance is calculating by the simple formula as the sound wave speed of the sound in air divided by the time it taken by the receiver to receive the signal from the object. So how the distance is calculated: when the robot detect it, simply stop, then reverse, and then again stop. It displays the message object detected. Prototype video.
So this is
part.
my prototype for the object detection module. So this is the four main components I have used for making this prototype. So first are motors, then battery, Arduino, L298 motor driver, Bluetooth, and LCD. The most main component which will detect the objects, that is the ultrasonic sensor. So I start explaining you. So first is the motor driver, which is L298 motor driver, which act as the main component in controlling the motors forward or bidirectional, and also this module is based on the H-bridge module. I have connected the LCD, which is based on the 16 pin module, which convert 16 pin module. These 16 pin are converted into 4 pin by the most main component, which is HW60 module. This HW60 module is also act as an MH module. So this MH module consists of the four main pins. First, power, ground, SD and SCL. SDA or SCL are connected to the A4 and A5 respectively. So the motor pins are 4, 5, 6, and 7. So now Bluetooth. The Bluetooth consists of the 4 pins positive, negative, TX and RX. These TX and RX are connected alternatively to the Arduino RX and TX. So this is the potentiometer. Hello everyone. So this is the video for the object detection. When I brought my hand near to it, it started detecting the object and print the message obstacle detected. Thank you.
Code explanation.
Hello everyone. So this is my code for the object detection. So I have included the library as the library is an important component for including, because if we haven't including the library, until and unless the component will not able be to execute the code. So I have now here is this is the liquid crystal address or I2C LCD address. This is which is 027, and many more LCDs also have 030 into 3F. This is 16 character and 2 lines. I have initialized the motor with the given pins, ultrasonic pins, and a variable which has an input of K char type. So in this mode, I have declared the pins or the motor pins as an output. These are ENA and ENB pin of the motor driver, which is also acting as an output pins. Here is the echo and triggered pin of the ultrasonic sensors. These pins are 8 and 9 respectively declared above. This is the echo and triggered pin. Serial dot begin. These functions help in communication between the Arduino and a laptop. This is LCD dot begin to help in executing the functions respectively. So in volt loop we have declared a potentiometer variable, which is an int type, which is reading the analog input from the potentiometer from the A0 pin. The value stored in the potentiometer is then passed into the portent, which is divided by 4. The analog write. The value of the portent are passed to the pins 10 and 11, which are ENA and ENB of the L298 motor driver respectively. Now, the distance from the object to the prototype is calculated through the variable distance, which is equal to a get distance function, which will discuss in the last. Here, it is the if loop. The if loop, when the distance gets the value from the get distance, which is less than or equal to 25, the stop function execute, then backward, then again stop. After backward there is a delay of 500 milliseconds or half seconds. The LCD also prints the message obstacle detected. And then there is else if case, when the Bluetooth is connected, or if the serial dot available, which means the Bluetooth is available, then it will send the message from the mobile phone, which is read as an serial dot read, which will read the value from the user, who will press the button on the mobile phone, then pass to the variable input of char type declared above. Then LCD.clear, which will clear all the inputs of the earlier printed message. This is the switch case. If like the user press F, then the F is stored in the input, which is passed into the switch case. The switch case will detect the string type F, and then according to it, it will execute the forward function by printing the message forward. Similarly, right, left, G, which act as a backward, stop, execute accordingly. This is the right function, this is stop, left, forward, and backward functions. So this is the get distance code, which will help in getting extracting the distance from the object to the rover. So this function starts by setting the triggered pin from to low and delaying for 2 microseconds. This is done to ensure that the sensor is stable in stable state before sending the trigger signal. Then trigger signal is set to high for 10 microseconds and then back to low. This sends a trigger signal to the ultrasonic sensor. The pulse in function is used to measure the duration of the echo signal, which is the time it takes for the ultrasonic wave to bounce off an object and return to the sensor. The duration is then multiplied by 0.034, as 0.034 is taken because the sound wave in air speed is 340 meter per second, which is then converted into centimeters and divided by 2 to get its desired value. This the calculated distance is then returned as an integer type. Thank you.